Right now, as you're watching this video, your device is talking to dozens of other devices you've never seen. A router, a switch, a modem, maybe a firewall, possibly an access point, sitting on a shelf somewhere in your house. None of them look impressive. Most of them are small, plastic, and quietly blinking in a corner, completely ignored until the internet stops working. But every single one of these boxes has one specific job. And once you understand what each one actually does, the entire concept of the network stops being a mystery and starts being a machine you can actually picture. In this episode, we're breaking down the core hardware that makes every network, from your home Wi-Fi to a global enterprise, actually function. Here's the mental model we're going to build in this episode. Every network device exists to solve one of three problems. How do I get onto the network? How do I move data efficiently once I'm on it? And how do I keep the wrong traffic out? Modems and access points solve the first problem, getting connected. Switches and routers solve the second, moving data to the right place. Firewalls solve the third, deciding what's allowed in and out. Keep that framework in your head. Every device we cover fits into one of those three categories. And by the end of this episode, you'll be able to look at any network, home or enterprise, and know exactly what each box in the rack is actually doing. Let's start at the very edge of your network, the modem. A modem's job is translation. Your internet service provider delivers internet access over a physical medium, fiber, cable, or DSL telephone line. And that signal isn't something your laptop or router can read directly. The modem converts the incoming signal from your provider into standard networking data your equipment understands, and converts your outgoing data back into the format your provider's network expects. Think of the modem as a translator standing at the border. Everything from the outside world passes through it first. Without a modem, your router has nothing to connect to. There's no internet on the other side of that cable to reach. One important distinction: a modem does not create your network. It doesn't assign addresses, it doesn't route traffic, and it doesn't understand which device in your house wants which data. That's not its job. Its job ends the moment it hands off a usable signal to whatever is plugged into it, usually a router. The router is the device most people actually mean when they say the internet box. A router's core job is exactly what the name implies. It routes. It looks at incoming and outgoing data and decides where that data needs to go next. At home, your router does two jobs at once. First, it connects your entire internal network to the modem and through it to the internet. Second, it assigns local addresses to every device in your house, your laptop, your phone, your smart TV, so that traffic knows where to go once it's inside your network. In an enterprise environment, routers do the same fundamental job at a much larger scale, connecting entire networks to each other, often across cities, countries, or continents, using routing protocols to constantly calculate the most efficient path for data to travel. The most important thing to understand about a router: it makes decisions. Every other device we've covered so far, the modem just passes signal through. The router is the first device in this chain that actually looks at data and chooses where it goes. Now that data has entered your network through the router, it still needs to get to the right device. That's the switch's job. A switch connects multiple devices within the same local network. Think of every device plugged in with an Ethernet cable, or every device on the same Wi-Fi network. When one device sends data, the switch's job is to deliver that data directly to the intended recipient, not blast it to every device on the network. This matters enormously at scale. Imagine an office with 200 computers. Without a switch intelligently directing traffic, every message sent by any computer would flood the entire network, congesting everything all the time. A switch keeps traffic efficient by learning which device is connected to which port and sending data only where it needs to go. Most home setups have a simple switch built directly into the router. which is why most people never see a standalone switch. But in any enterprise environment, switches are everywhere, forming the backbone that connects every desk, every server, and every device in the building. Every device we've discussed so far assumes a physical cable. But most of your devices aren't plugged in, they're wireless. That's the access point's job. An access point takes the wired network and extends it wirelessly, allowing devices like phones and laptops to join the network over Wi-Fi instead of Ethernet. In most homes, the access point is built directly into the router. That's the Wi-Fi your devices connect to every day. But in larger environments, offices, warehouses, campuses, a single access point can't cover the entire space. Enterprise networks deploy multiple access points, strategically placed throughout a building, all working together to provide continuous wireless coverage as people move from room to room. It's worth remembering, an access point doesn't route or switch anything on its own. Its entire job is translating wired network access into wireless access. Everything else, routing, switching, security, still happens elsewhere. So far, every device we've covered has one goal: get data where it needs to go as efficiently as possible. The firewall exists for the opposite reason, to stop data that shouldn't be allowed through at all. A firewall inspects traffic entering and leaving a network and makes a decision, traffic by traffic. Allow it or block it. That decision is based on a set of rules: which ports are open, which sources are trusted, which types of traffic are permitted. At home, this often lives quietly inside your router, filtering out obviously malicious traffic without you ever noticing. In an enterprise environment, the firewall becomes one of the most critical devices on the entire network, a dedicated appliance sitting at the edge, enforcing strict rules about exactly what's allowed to enter and leave. Without a firewall, every other device we've discussed will happily move any traffic it's given. A router routes, a switch switches. Neither one asks whether that traffic is dangerous. The firewall is the device whose entire purpose is asking that question. Let's put the whole picture together using one simple example: you opening a website on your laptop at home. Your laptop sends the request over Wi-Fi to the access point. The access point hands it to the switch, often built into the same box as your router. The switch forwards it to the router, which checks whether this traffic is allowed to leave your network, often through basic firewall rules built directly into the router itself. The router hands the request to the modem, which translates it into a format your internet provider can carry. And that entire chain, access point, switch, router, firewall, modem, happens in a fraction of a second every single time you load a page. Scale this up from your living room to a global enterprise, and the concept doesn't change, only the scale, the redundancy, and the complexity of the rules involved. Every device in this episode exists to solve one of three problems: getting connected, moving data efficiently, or keeping the wrong traffic out. Once you can look at a network diagram and immediately know which device solves which problem, you're no longer just a user of the network. You're starting to think like the people who designed them. In the next episode, we go one level deeper into how these devices actually communicate with each other, using the addressing and protocol structure that makes the entire internet work, IP addressing, and the basics of how data is actually packaged for its journey across a network. Thanks for being part of the Network Chronicles community. If you enjoyed this lesson or have any questions, drop a comment below. I genuinely enjoy hearing from you. And if there's a networking concept you'd like to see explained next, let me know. Your ideas often inspire future videos. Until then, keep learning, keep experimenting, and keep building. I'll see you in the next lesson.